This is a story from the year 2006, when scientists around the world detected a poisonous gas in our atmosphere, methane. It was observed that the concentration of methane gas in the atmosphere had suddenly increased, and it has continued rising ever since. Methane is a type of natural gas, and if it is released into the atmosphere, it acts like a blanket around the Earth, trapping heat. Just like we use a blanket in winter to stay warm, methane wraps around the Earth and keeps the heat inside, making the planet warmer. What's more alarming is that methane is even more potent than carbon dioxide when it comes to heating the Earth. When this sudden spike was noticed in 2006, scientists initially assumed it was due to pollution caused by human activity. But when investigations were carried out, the findings shocked everyone. This was a massive secret that the Earth had been hiding within itself. So where did this methane come from? Why is it continuously increasing? How does the scientific community detect methane? And more importantly, is this a sign of the end of the world or the beginning of a massive climate shift? Welcome back to English Story Worlds. Scientists already knew that spikes in atmospheric methane usually happen about once every 100,000 years. This data is uncovered by extracting ice cores from frozen regions like Antarctica and Greenland. Here's how it works. Let's assume Antarctica receives 1 meter of snow every year. Trapped within that snow is a sample of the Earth's atmosphere. The next year, a fresh layer of snow covers the previous one, and this cycle continues. When scientists drill deep and extract long cylinders of ice, called ice cores, they are essentially retrieving frozen records of ancient atmospheres, like a time machine. From these, scientists deduce what gases were present in the air during different centuries and in what amounts. And through this, they discovered that roughly every 100,000 years, the Earth's atmosphere experiences a sharp rise in methane. This is considered a signal that an ice age is ending and the Earth is about to begin warming again. Once the ice age starts ending, it only takes about 2,000 to 3,000 years for a significant amount of ice to melt and the Earth to reach a climate similar to what we have today. But here's the issue. Such levels of methane were last recorded 12,000 years ago, which marked the end of the last ice age. So why is methane increasing again so soon? Is the Earth heading toward a major transformation? Or are we facing a new threat? To understand this mystery, we need to take a look at Earth's geological history. We are currently living in a time period called the Quaternary period, which began about 2.5 million years ago and continues today. This period is divided into two parts. 1. Pleistocene epoch from 2.5 million years ago until about 12,000 years ago. During this time, Earth repeatedly entered and exited ice ages. Massive portions of land were covered in ice, then warmed and became habitable again, only for the cycle to repeat. This was also the time when human evolution progressed and large creatures like mammoths went extinct. 2. Holocene epoch began around 12,000 years ago and continues today. In this warmer, more stable climate, humans learned farming, built civilizations, and benefited from the freshwater resources created by melting glaciers. Settlements began near water sources, and human societies flourished. Now here's a confusing part. Technically, we are still in an ice age. Why? Because Earth's poles still have ice. Only when the polar ice caps have completely melted can we say the ice age is truly over. So what causes the Earth to warm and an ice age to end? Scientists have identified three major natural cycles known as the Milankovitch cycles. 1. Eccentricity. Earth doesn't always orbit the Sun in a perfect circle. Sometimes the orbit becomes more oval-shaped. When Earth is closer to the Sun during this phase, it receives more solar energy. This cycle spans about 100,000 years. 2. Axial tilt. Earth is tilted at about 23.5 degrees, but this tilt varies over time between 22.1 degrees and 24.5 degrees. When the tilt increases, the poles receive more sunlight during their summers, accelerating ice melt. This tilt cycle lasts about 41,000 years. 3. Precession. This is the wobble in Earth's rotational axis like a spinning top. It affects the timing of the seasons and occurs over a 19,000 to 23,000 year cycle. These three cycles together trigger the natural warming of the Earth. Here's how the cycle works. Ice reflects sunlight very effectively, but when it melts, the darker surface beneath, like soil or ocean water, is exposed. These darker surfaces absorb more solar energy, which causes more warming, which melts more ice. It's a self-reinforcing loop. Eventually, the warming causes trapped greenhouse gases like methane and carbon dioxide to be released from oceans or permafrost, permanently frozen ground. This further accelerates global warming. So the question remains, if this natural process already happened just 12,000 years ago, why did we see another huge methane spike in 2006? Shouldn't the next one have occurred after another 100,000 years? Well, from the year 1900, as the natural gas industry expanded, methane emissions due to human activity also rose. But by around 1990, they had reached a plateau. So where did the 2006 spike come from? Here's the catch. Methane is also produced naturally from wetlands, oceans, and melting permafrost. That's right. Melting ice unlocks massive reserves of trapped methane. Thanks to today's advanced satellite technology, scientists can now identify where methane is leaking from. Here's how it works. Satellites send down a laser beam with a specific wavelength that only methane can absorb. If the beam doesn't reflect back to the satellite, that means methane absorbed it, indicating its presence at that point. Using this method, scientists have created a methane map of the entire Earth. For example, NASA teams discovered a 3-mile-long methane cloud over a massive landfill in Iran. This site releases 73,440 tons of methane every year, equivalent to the weight of 180 jumbo jets. That's about 8,500 kilograms per hour. Even more alarming is Turkmenistan, where oil and gas fields were found to be releasing 400 kilograms of methane per hour at 12 different points. But here's the twist. These industrial sources explain only half of the spike. The real culprit? Forests. Specifically, forests that were once growing on top of permafrost. Now that the permafrost is melting, the ancient organic matter beneath is decomposing rapidly, releasing massive amounts of methane into the air. And here's the biggest problem. Methane from forests cannot be collected. Unlike landfills or gas fields, where special systems can capture and reuse methane, often converting it into energy, forest emissions are impossible to manage. In modern landfills, methane is collected and converted into carbon dioxide, a less dangerous gas than methane. Methane stays in the atmosphere for around 10 years, after which it turns into CO_2 and water vapor. Now methane levels have spiked before, like 12,000 years ago, but that was during a time when the planet was naturally transitioning out of an ice age. What's concerning now is that we're seeing similar methane levels today, but without an active ice age ending. This suggests Earth might be heading into a completely new phase. But honestly, predicting what comes next is extremely difficult. Will we finally exit the current ice age? Or are we heading toward another one? The truth is, the scientific community has no historical reference for methane levels rising like this after only 12,000 years. And even more alarming, we don't know how high these levels will go. If this rise is natural and not man-made, then stopping it might be impossible. Thanks for watching.